Okay, this is my solution for the problem that we did Wednesday of week 5. And following the pattern that we'd really set up here, we had the same resistor network. This time we took the network and we hooked it up to a battery. So we have this battery here, and you can imagine each of these resistors as a light bulb. And we asked the question, find the rate of energy dissipated. Which is another way of saying find the power. Power. So we said that, and just in case you're having trouble remembering this, remember that a power is an energy per time, and an energy is a charge times a voltage by time, and a charge per unit time is just a current. So P is equal to the current, these two things together, times the voltage. Okay, so let's see. How do we do that? Well, let's again number these resistors. So we'll number them 1, 2, and 3. And I'm going to start with resistor 3 because I can see right away that that has 12 volts across it. It has the whole, so if I go from the battery and then I go up here, over here, up here, over here, down here, here, it has to be 12 volts because by the time I get back through the wires, which has very little potential difference in it, I have to be back at the battery. So that means that the voltage across the third resistor is 12. Unfortunately, I don't know the current, but what I do remember is that V equals IR. So I'm going to put this up in a little bubble here to remind me that V also equals, I don't know what that was all about, IR. There we go. And so instead of I in the power equation, I'm going to put in V over R times V. So this is equal to V squared over R, which is 12 volts divided by 2 kilo ohms was this one. Okay. Oh, and this was squared. Right. Okay. What about the other two? Well, let's see. How do I want to handle this? Well, do I know the current through them? I don't really. And do I know the voltage across them? Well, I don't really know that either. But what I do know, because all I know is that it has to add up to 12, so that's all I really do know. And so what I do know is that for the equivalent of 1 and 2, so I'm going to think about the current through 1 and 2 equivalent. Because that has to be the same as the current through 1 and the current through 2. So I might think about that. So I remember from the previous day that we found that the combination of those two resistors together was equivalent to a 9 kilo ohm resistor. And so the equivalent here was 9 kilo ohms. Okay. But that 9 kilo ohm resistor would then have 12 volts across it. Oh, so that means that the current through this equivalent thing, which is also the current through each one individually, has to be, let's see, I is V over R, so it has to be 12 volts all over 9 kilo ohms. Okay, so that means that the power dissipated by resistor 1 is IV. Well, I still haven't figured out the voltage, so I'm going to rewrite this as I, and I'm going to write the voltage as IR, so that's the same thing as I squared R. But now I actually do know what the resistance is, and that's going to be 12 volts over 9 kilo ohms squared. But now I'm looking at just the power dissipated by 1, and that's 3 kilo ohms. Likewise, the power dissipated by resistor 2 is going to be the same thing, that same same current that they have in common times its resistance, and so that same current they have in common is 12 volts, 9 kilo ohms squared, this time times the 6 kilo ohm resistor. So just to review, if I'm finding the power dissipated by 3, I want the, let's see, where am I going with this? Oh yeah, the voltage across 3 times the resistance of 3, 3, 3, 3. And if I want to find the power dissipated by 1, I want this to be 1, 1, 1, 1, 1, 1, 1. And if I want this to be the power dissipated by 2, it's 2, 2, and so on. It's just that 1 and 2 have the same current. Okay, so now I can actually find my calculator and plug in some numbers here. So I'm going to do do them in order. So resistor 3 has 12 volts times 12 divided by 2 kilo ohms is equal to 72 milliwatts. Okay, and P1, so I have 12 squared again, divided by 9 squared times 3, and I end up with 5.3 milliwatts. And then if I do resistor 2, I have 12 squared divided by 9 times 6, and that answer is 10.7 milliwatts. Okay. Of course, on the other hand, really to check this, I can use from yesterday that this is equivalent to one resistor that has a resistance of 18 over 11 kilo ohms. So if I take that one resistor and I put it over the 12 volt battery like this, I can just use that the power is equal to V squared over R, which is 12 volts squared divided by 18 over 11 kilo ohms, which is 12 by 18 is 88 milliwatts. So, if I did this right, then I should check. So P1 plus P2 plus P3 is equal to 5.3 plus 10.7 plus 72, and sure enough, when I add those up, 88 milliwatts. Cool.